Today's lesson is on decimal tenths greater than 1. Now, you might be wondering, how would we write a fraction for a decimal tenth that's greater than 1? We know that 10 tenths equals 1, and we see that right here. So how can we write something that's greater than 1? Well, let's take a look at the pictures that we have here. Now, our denominator, or our bottom number in our fraction, is going to stay as a 10 because we are working with tenths. And if we look at the first picture with the pencil crayons, if I said to you, what fraction of the pencil crayons is sharpened? You would look at both packages. The first package has 10 pencil crayons that are sharpened, and the second package has 4 pencil crayons that are sharpened. And when I add them together, 10 plus 4 is 14. So we would say 14 tenths are sharpened. Over in the 10 frame picture, we see that there are 10 dots colored in the first 10 frame, and there are 4 dots in the second one. Again, 10 plus 4 is 14, so we say 14 tenths are colored. Now, 14 tenths has a whole in it, because remember, 10 tenths is equal to 1 whole. So what we're going to do is we're kind of separating the whole and the part to make a decimal number. So the whole, the tenths, that would be our whole part of our decimal. Our decimal would then come after, and then the leftover part, which would be the 4, would be the 4 tenths. So 14 tenths is the same as 1 decimal 4. Same with the other fraction. The decimal 1 decimal 4 is the same as 14 tenths. The 1 represents the whole, the 4 represents the part, the 4 parts that are left over. Now we can also see what it looks like to have it in a place value chart. So again, when we're talking about the whole pencil crayon case that is colored, or sorry, not colored, but is sharpened, that refers to the 1. Same with the 10 frame. The whole one that is filled in refers to the 1 whole. And then it's the parts that refer to the back part of the decimal, or the tenths. 1 represents the whole number, the tenths are represented by the 4. 1 decimal 4. In reality, anything after the decimal point represents any number that is smaller than a 0. The 3 terms you need to be aware of when working with decimal tenths greater than 1. The first one is an improper fraction. That's a new term for us. An improper fraction refers to any fraction where the numerator, or the top number, is bigger or greater than the denominator, the bottom number. In this improper fraction, we see 17 tenths. We also can write 17 tenths as a decimal, which we learned in our other lesson. 1 decimal 7 would be the decimal number for 17 tenths, because we have 1 whole and we have 7 tenths left over. And the final new term would be a mixed number. So a mixed number is when we take the whole and the part and we put it together as a whole number and a fraction, very similar to what we did in the decimal. So the 1 whole in the front of the decimal becomes a 1 whole on its own, and then the decimal 7 part, which is really 7 tenths, we write as an actual fraction 7 tenths. So we say the mixed number as 1 in 7 tenths. Now let's look at decimals on a number line or on a measuring tape. So first of all, at the top I have 10 decimeters is equal to 1 meter. So if you see, one of these here is a decimeter. And then from here all the way to here is 1 meter. So 10 decimeters put together make 1 meter. Now the number that we're actually working with today is 1.1 meters. So again, we have the whole, which is the whole meter. That's where we get the whole number from, that part of the decimal. And then the 1/10 that's left over is where we get the second part of the decimal. We could also write that as 11 tenths for an improper fraction, because if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts shaded. If we want to write it as a mixed number, we would write it as 1 whole and 1/10 left over. Let's look at another number line with frogs jumping. So we can see over here, 1.7 is the decimal number that we're working with. So we want to put that first into an improper fraction, which means our numerator or our top number will be larger than our denominator or our bottom number. So if we have 1.7, that would be 17 tenths. How do we know that? Well, we can count up the parts on the measuring tape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 tenths. When we write it as a whole number, again, not as a whole number, as a mixed number, first we look at the whole number. So if I go from here to here, that's 1 whole meter. So that's where I get the 1 from. And then the leftover parts, we have 7 more tenths, or 7 more decimeters. So it would be 1 and 7 tenths. Okay, let's look at our last number line with frog jumps, and we're going to do the same thing. So again, we want to look at the number that's here, and they've given us 2.3. That's the number that we have to come up with the fraction for. So first, we're going to put the denominator, which we know is going to be 10, since we're working with tenths. And for the top number, we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1 full meter. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is 2 full meters. 21, 22, 23. So our fraction would be 23 tenths. We have 2 whole meters, so our mixed number would have 2 as the front, and then we have 3 decimeters, or 3 tenths, that are left over. So it is 2 and 3 tenths for our mixed number. Now let's try some examples without the number lines. So we're going to turn these improper fractions into decimals and mixed numbers. So let's start with 28 tenths. We can write that as 2 decimal 8. For a mixed number, we would have 2 wholes and we would have 8 tenths. So it would be 2 and 8 tenths. For the improper fraction 34 tenths, it would be 3 decimal 4, and it would be 3 and 4 tenths. And then for 16 tenths, it would be 1 decimal 6, and it would be 1 and 6 tenths. Now let's try that with decimals, turning them into improper fractions and mixed numbers. So if I have 2 decimal 5, the mixed number would be 2 and 5 tenths. And the improper fraction would be 25 tenths. Oops, sorry, my 5 didn't go there. 1 decimal 2 would be 1 and 2 tenths. And the improper fraction would be 12 tenths. Then 3 decimal 9 would be 3 and 9 tenths. And the improper fraction would be 39 tenths. Lastly, let's try putting these mixed numbers into decimals and improper fractions. So if I have 1 and 8 tenths as a decimal, that would be 1 decimal 8. As an improper fraction, that would be 18 tenths. For 3 and 7 tenths, the decimal would be 3 decimal 7, and the improper fraction would be 37 tenths. 2 and 3 tenths would be 2 decimal 3, and the improper fraction would be 23 tenths. Sorry, there goes my dog again. Hopefully now my dog's had his barking out and he'll be quiet for us. Sorry. So now we're going to look at just converting a little bit. We know that there are 10 decimeters in a meter. We learned that a long time ago when we did our measurement unit, and we can see on this measuring tape 1 decimeter is just that little one between 0.0 and 0.1. 1 meter would be 10 of those decimeters all together. So the 1 meter actually spans from here all the way to here. That's 1 whole meter. So now we want to look at converting. If I had 11 decimeters, how much would that be in meters? Well, let's take a new color and we can do that. So if I want to look at 11 decimeters, we could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's where 11 decimeters would be. So as a decimal, that would be 1.1 meters. There's 1 meter and 1/10 left over. If I have only 6 decimeters, what would that look like? 1, 2, 3, 4, 5, 6. So we can see that is 0.6. We don't actually have a full meter, we just have 6/10 of a meter. In the last question, this won't actually fit on our measuring tape, but I want to see if you can use the same rules that you're seeing here to try to figure out what would 24 decimeters be as a decimal, and that would also tell us how many meters 24 decimeters is. Can anybody guess? Well, if you guessed 2.4, you are correct. 2.4, we would have 2 whole meters and we would have 4/10 left over. So hopefully this video has given you a better understanding of decimal tenths greater than 1, and hopefully the new terms improper fraction and mixed numbers and some of our conversions with decimeters and meters has also become a little more clear for you.